All right, this is part of a two-part video helping my students understand how to deal with well data, getting ready to practice for their ASBOG exam. This is an unofficial video. I'm not sponsored or affiliated with ASBOG in any way. I'm just a professor trying to help my students prepare for their exam. So, in the first video, we dealt with gradient, how to get gradient from a map like this. But what happens if you're given 3 points and you're asked about where you might get a strike and dip or an attitude of a rock unit that is seen in these 3 wells. So we're going to talk about the Sturgis limestone. It hits at 2,000 feet below the surface at sea. So at sea, our ground surface elevation is 6,000 feet. 2,000 feet below the surface would be 4,000 feet. When we talked about our aquifer, I use these little water symbols. So for this problem, I'm going to specify everything in red that has to do with this, and we'll have a little brick symbol for our limestone. 100 feet below the surface at A. So 5,000 minus 100 is 4,900. I think I skipped B. 200 feet below the surface at B. So 3,800 feet at B. All right. So what is the strike and dip of the limestone? This is where multiple choice is going to be your friend until it's not. So this is the highest elevation out of these 3. Even though 5,000 feet is less than 4,000 feet, if we went down below the surface, this is indicating that we hit the limestone unit at a higher elevation than we do in these other 2 places. And this is the lowest elevation where we're going to hit that limestone unit. So here's how to think about this. If we're going to try to figure out the orientation of strike of the bed, we are going to imagine going from high to low, and the strike is going to be perpendicular from that high to low direction. Okay, so this is our highest elevation, this is our lowest, and this is our intermediate one. If you are just looking for a quick and dirty way to do this, find the intermediate one, the intermediate elevation. Imagine which of these you're closer to and about by how much. So for example, I'm only 200 feet different from this over here, but I'm 900 feet different from that over there. So I'm definitely going to fall closer to B in the grand scheme of things. So I could imagine that my strike is something like this, and I'm going to be dipping in the direction of the lower elevation. I'm not going to dip toward my higher elevation. So if you have a range of choices where you're looking for strike and dip, and your strike choices are northeast and your dip is southeast, your strike choice is northeast and your dip is northwest, strike choice is southeast with a dip to the northeast, or strike choice is southeast with a dip to the southwest, you don't have to do any math at this point. You can just come in and say, well, my intermediate value would fall somewhere in here. My dip is out toward my lower elevations perpendicular to my strike, and that is in the southeast direction, so I'm done. But the problem becomes, what if you have 2 northeast, southeast choices, but they're just to different amounts? So let's help you differentiate between those 2 values should that come up. So we're going to find exactly where C would plot between A and B. So I'm going to draw this line from A to B. And what that is representing is an A at some elevation and a horizontal distance to B, which is at a lower elevation. There is a distance between the 2 horizontally and a distance between the 2 vertically. The vertical distance between the 2 is just this minus this, so that's going to give us 1,100. And the horizontal distance between the two you would measure off the map. So you'd come over here, get a horizontal distance marked on your ruler, come down to your map scale. Okay, so I'm getting about, let's see, a little over 7,000. Make sure that was right. Yeah, a little over 7,000 because I had 4,000, 5,000, 6,000, 7,000. Let's go with 7,500. So there's 7,500 feet between those 2 points on a map. And then we can figure out where along this vertical elevation, and more importantly, where along this gradient between the two, where does C plot? So C is 4,000. It's definitely going to be closer to the 3,800 mark. So if we say, well, I'm going to go up to 4,000, which means there's 200 feet of elevation difference between the two. 200 divided by 1,100 is roughly 0.18. So you're going about 18% of the way across. And 18% of 7,500 is, let's see, 0.18 times 7,500. So we're going about 1,300 up in this direction too. It's actually 1,350. Okay, so from point B to point A, I am going to go 1,350 feet in that direction to get toward A. Now 1,350 is going to plot right here-ish. So I'm going to record that amount. Put my, whoop. Yeah. Make sure I get my point in the right direction. Put my point. That is where C would plot. So now I can connect this C with this C. That is the strike of my beds. And you could stop here. If these strikes are considerably different, you can go up. Remember, you're measuring from north, so you're measuring from vertical. You can come over and get 20 degrees, so north 20 east. If you have north 20 east and north 45 east to choose from in terms of strike, then here's where you can stop. But if you have two north 20 east and the dip is just different, what would you do from there? So from there, what you can do is draw another strike line at a known elevation, which is 3,800. It needs to be parallel to the last strike line you drew. And then you would measure the horizontal distance between these two. And you know the vertical distance because you know that this is the 4,000 foot strike line and this is the 3,800 foot strike line. So here's what my triangle looks like for this. I know that I go up and down. I go vertically 200 feet. Laterally, I need to measure. Let's see. Comes to right here. So maybe 1,700. This is just an estimate, but that's all you're going to be able to do too, so that's fine. And then dip is angular distance from the horizontal. So this is my dip amount. This is my dip direction. is in this direction is coming down to the south southeast or east southeast. And I know that because 4,000 is greater than 3,800. So this is kind of rolling downhill in this direction. So over here, I want opposite over adjacent, which is tangent. So I'm going to do arctangent of 200 over 1700. Make sure you have your calculator set to degrees. Atan 200 over 1400 in degrees. All right, and I get 8.13 degrees. So I'm just going to do 8 degrees to the east, southeast. All right. So, just to recap, the goal, if you have really different choices, is just to go from your intermediate elevation in between your highest and lowest elevation, but about where you think it would go in terms of which number it's closer to. So here, 4,000 was significantly closer to 3,800 than it was to 4,900. So I kind of knew that I was going to come closer to B, but I didn't know how much closer. I mean, precisely. So you know that it's this direction. You know the dip is going downhill. So from 4,000 to 3,800, I knew I was going down this way. If you have a diversity of choices, you can do it that way with no math. But if you have multiple choices that are pretty similar, then you can make your triangle, calculate where you lie along this line, draw this line in, and that'll give you your strike. Dip is going to be 90 degrees to strike, and you're only going to be able to calculate dip if you draw in multiple strike lines. Okay, thanks.